Question number 2C says, find the distance between Stephen's position at t equals 20 and his position at t equals 80. So we want to find the start position, the end position, and the distance in between. So the key idea is that the area under the velocity function represents displacement. And the distance between the start point and the end point is just we find the net displacement, and to make a distance, we just take the absolute value of that. So we want the absolute value of the difference in position from t equals 20 to t equals 80, and I've represented it in the integral form in the absolute value. So to do this, we need to use the integral function number 7. So putting that into the calculator, we're going to end up with the distance. So when I integrate this, so the distance is equal to 23.3839 or 4. And taking the absolute value of that, we just end up with 23.384. Okay, and that represents the total area or the displacement above and below the x-axis. So the above part represents a positive displacement to the right, and the blue area underneath represents a negative displacement to the left, and the net displacement or the difference in those is going to represent how far apart the swimmer is going to be from the time at 20 and time at 80. For part D, it says find the total distance Stephen swims over the time interval from 0 to 90 seconds. So the total distance is going to be the positive displacement we need to calculate as distance, and the negative displacement, instead of counting against that, we're going to count it with that positive displacement. So we need to take the absolute value of the area under the velocity. So to do this, we need to make sure that we recognize when we go from above or positive velocity to negative velocity, and we need to know the zero. So we have to make note that the zero is at 56 seconds. And we're going to then calculate the total distance by taking the absolute value of the velocity, the area under the velocity function from 0 to, it's going to be 0 to 56. So the area under the velocity function, okay, and that's going to be represented by that red area above. And then we're going to take the absolute value of that. And then we're going to add that to the area below, taking the absolute value of that. So from 56 to 90, 56 to 90 seconds of v of t dt. Okay, so again, we're going to use our graphing calculator for this. We're going to use that function, the integral function number 7. And in doing that, we get 49.9216 above. So you can see that I've noted that on there. And take the absolute value of that. And we end up with negative 12 point, maybe I'll do an extra step here. So I've find that area. And the area from 56 to 90 is going to be negative 12.2427. Because that is absolute value, we take the positive and we add those together. We're going to end up with 62.1643. And that's going to be in It looks like that's going to be in meters. So that's the total distance they travel. Part of it is to the right, part of it to the left. Now we can also do this. The total distance can also be calculated by using the absolute value of the actual function v of t. And what that does is when we graph this, and if you graph this on your graphing calculator, it just, instead of going below, it's just going to be symmetrically above like that. And then when you take the area, you can integrate from 0 to 90. It'll take the area under that curve, and that area is going to be entirely above the x-axis, so it'll be entirely positive. And you get the same value when you do that.